In this lesson, we focus on mathematics, WTW158, and we shall cover calculus, limits, derivatives, integrals, vector algebra, and a lot more. And we shall switch between these topics as follows. Okay, there's some of the questions that have become so popular when I started the assessments, and I soon realized that it would be very important to sort of, put together the kinds of topics the kinds of questions that appeared the most in most of the past assessments when I was doing analysis of the past assessments. And I wanted to sort of highlight a collection of popular questions in this particular module. So the largest interval on which the function f of x equals x minus 2 minus the square root of 3 minus x, the largest interval on which the function is continuous. Is what? Right. So you'll actually be in a position to see that now the largest interval in which it is continuous, we remember last time we said that it's going to be where x is greater or equal to 0, but also where 3 minus x is greater or equal to 0. And it will be when x is greater or equal to 2, and whenever 3 is greater or equal to x, or you can write x less equal to 3 here. Right, and what is this? You have exactly this. So now, as a consequence, if you graph this on the real line, so you'd have like 2 to 3 greater equal to 2 and less equal to 3. Okay, so you'd look at the fact that these must both be true, which means therefore that 2 is less equal to x less equal to 3, or x is an element of the interval from 2 to 3, like so. So this would be the largest interval. So, and that would actually be, for instance, f, which is exactly 2 to 3 there. Some of these I'm going to ask you because these are the most popular questions, and some of which we have discussed before. I'm going to pose some of the questions to you. You'll forgive me because well, I must be fair to you, but also the way to be fair, I must, give you a chance to try some of the questions to make sure that, in the end, you understand everything. Okay, let's look at this one. So you have arctan for x. You have arctan for x. So what do you think this limit is? What would you think this limit is exactly? What would you think this limit is precisely? Let me know when you're done, please. Let me know, please, when you're done. Right. So please let me know. So today's discussion is an open discussion. I'm trying to make sure that you're able to try the questions along. Right. So now at this point, the question you're asking is, what exactly is this? What exactly is the limit here? Please, when you're done, let me know. It's a recap of this discussion. It's a recap. It's a recap. All right, so it's a recap. Please let me know when you're done. Just want to see exactly how well you can do. Just want to see how well you can do. Just want to see how well we can do. Right. You done? Um, please let us know when you're done. Let us know when you're done. Please let us know when you're done. Right. Please let us know when you're done. All right. Okay. You'd be able to see that first and foremost, there's a graph that goes with this. So you'd have that. So the graph associated with this function arctan of 4x indicates that whenever this one is minus pi over 2 radians, and this is pi over 2 radians. But now if we are progressing in the negative infinity direction, you would see therefore that the graph approaches minus pi over 2, so this is going to become minus pi over 2 radians, and therefore the answer would be part B there. Part B there. Right. Just reviewing some of the questions. Right now, we have been given a function here, the critical numbers of this function. So if you have been given the function f of x, which is ln x minus x, we're asking the question, what are the critical numbers of the function? Please try this question. When f of x equals ln x minus x, what are the critical numbers of this particular function? Ln x minus x. Ln x minus x. Right, please try it, and as soon as you're done, please alert us that you're done, and then we can see what to do. And then we can see exactly what to do. Right, then we can see exactly what to do. Right, then we can see exactly what to do. Right, then we can see exactly what to do. Right, please alert us. What are the critical numbers of this function? What are the critical numbers of this particular function? What are the critical numbers of this particular function? Right. You'll note, therefore, that at this point, you would actually, we already have the derivative, which is 1 over x minus 1, and this would be, we are interested in where this actually is equal to 0 for the critical numbers, and this means 1 over x is 1. And now this means x is 1. And if you look therefore very, very carefully, you are able to see, that in this case, when your x is 1, then you'd have that your c, the critical number, is also c equals 1. Right, and if the critical number is c equals 1, then that would actually obviously mean that the correct answer is actually exactly A, where c equals 1. Right, and that is exactly the answer. We move on to the next question. Okay, now the couple of things that obviously remain very important. Right, so the equation of the tangent line to the curve in the point where x is minus 1 is what exactly? So you'd need y is actually x cubed plus 4. dy dx would be the derivative of this, would be 3x squared. And we're interested in finding the equation of the tangent line. And therefore, we have dy dx at x equals minus 1, which is 3 minus 1. You square it, and it becomes 3. And this is therefore the slope you can call f, which is the gradient of the tangent line. And you can use y minus y1 is mx minus x1, which means that if you are actually looking at the fact that it passes through x equal to minus 1, so whenever you have the fact that y itself is x cubed plus 4, y equals minus 1 cubed plus 4, and therefore this becomes exactly 3. So whenever x is minus 1, y equals 3. So that in the end, then we're able to achieve exactly the following. Through this, which means that we have x1, y1. So you have y minus 3. The slope is actually exactly 3x minus x1, which is minus 1, which means that you're going to have here 3x, and here you have plus, which is exactly 3 plus 3, and which is exactly 3x plus 6. 3x plus 6. So we need the equation of the tangent line, and we can see therefore that the equation of the tangent line is actually the part B there. Right, and we are recapping on some of the questions that are highly examinable. We move on. And right, moving on, we actually consider the following statements. We're able to see that statement 1 states that the natural log of b squared, for example, is 2 ln A ln B. The ln of 3, is it the same as the ln of 6 minus ln 2? The ln of e to the power x is 1. Is it true or false? So now we need to reason this out, but checking this out, we emphasize the fact that at this point, what we're able to achieve, it is that obviously which of the following is therefore the correct answer, and what we're able to see here is the fact that in looking at this, the 1 is incorrect. Right, so we have that the first one itself is certainly incorrect. And now this ln here is the ln of 6/2, and 6 divided by 2 is 3, so that we have ln 3. Indeed, this is ln 3, so we are actually making a recap on the fact that this is indeed the correct result. And now the ln of e to the power x, right, is actually x ln e equals 1, and the ln e is 1, and this is 1, and this means x equals 1, and this means that this is actually x, and it is not equal to 1. So in other words, that would mean therefore that is also incorrect. As a consequence, we're asking the question, choose the correct answer. And the correct answer should be the answer that says that statement 2 is correct. So it is obviously option B there. Right, and we move forward. Right, in the next question, we recap on our study of hyperbolic functions and some of the results that remain very, very poignant. And we then have the following. So if ever you have f of x is 3 ln x, f primed of x, the derivative of this. So consider the following statements. If f of x is 3 ln x, then the derivative would be of the ln x becomes 1 out of x, so that this is 3 out of x. Simultaneously, if ever f of x is this, then is the derivative equal to 3 times the function? So we need to investigate that part, because in part, this was in part 1, and in part 2, we have f of x, which is the hyperbolic sine of 3x plus the cosh of 3x, which means that we have f prime of x, the derivative of the hyperbolic sine is 3 the cosh of 3x plus 3 the hyperbolic sine of 3x, which is f primed of x, which is the cosh of 3x. And then this is actually the hyperbolic sine of 3x. And what is actually the f primed? So, which means that here, if you have the hyperbolic sine of 3x, the cosh of 3x, it is actually f of x. So f primed is indeed f of x. So that means that these first two are indeed correct. Let us look at the other part. Right, so in the other part, we have f of x equals e to the power 3x. Is it therefore true that then you actually can be in a position to deal with the actual derivative? Let us check this. So what is the derivative of minus x? So first things first, we can be able to find the derivative, and the derivative is actually 3e to the power 3x, because you find the derivative of the 3x by the chain rule, and it becomes 3, and you multiply by e to the power 3x. Then now you need to say f primed of minus x, which is actually minus 3x in this particular way. And indeed, we agree that it is 3. And now we can actually be able to see e to the power minus 3x is f of minus x. And as a consequence, then we recap on this, and we're able to see that all of them are correct. In other words, we can see that number 1 is correct, but we can also see number 2 is correct. We can also see number 3 is correct. And as a consequence, we have correct, correct, correct. And with correct, 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 it means, therefore, at this point, the correct answer is option G, that says, that's actually indicates that statements 1, 2, and 3 are correct. So we're good, and we sorted that. And we move on to the next point. We move on to the next point. We move on to the next point. The next point is as follows. Right, I would wish to give you this limit here. It's a very popular limit. I've seen this limit in many examinations. So what would you say it's this limit here? I'm giving you like a minute to try this one, and please let me know as soon as you're done with this limit. Let me know as soon as you're done with this limit. Now the question therefore is, what exactly is this particular limit here? Right, what exactly is this particular limit here? Right, what exactly is this particular limit here? Please let us know as soon as you're done with this limit. Alert us immediately so that we can be in a position to exactly get the required result. I want to know what this limit is precisely. Right, 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 right. Want to see exactly what we have here. Right. Okay. Now, a couple of things you need to recall when dealing with limits of this nature. One of the most important aspects of the limits is to then think that this limit, if you take the limit straight away, so this would be infinity, and this would become, for example, 0, because it should be e to the minus infinity like this, which should be that to 0. In which case, we have the limit as x approaches infinity. And then it is actually x squared e to the power x. Right, and now this would give us infinity squared, which is infinity out of infinity, and then we're able to use L'Hopital rule. And the derivative of x squared becomes 2x, and the derivative of e to the power x becomes exactly that. As x approaches infinity, we are able to make the observation that this here, it's still actually infinity out of infinity. And we want to be in a position to get the actual result. So what we then have is that we still have the limit as x approaches infinity of 2x divided by e to the power x. And if you differentiate this, we remind each other, it's going to be 2 divided by e to the power x. And as x approaches infinity, it's going to be 2e to the infinity, which is 2 infinity, and this one becomes exactly a 0. And upon careful exam, we are able to see, therefore, that the correct result is this one here, where a and the limit is identically 0 there. Then we move on to the next question. We move on to the next question. Right, we need to consider the following statements. Here in question 8, we have been given lots of things. So the domain of f of x, which equals 1/2 to the power x, is this one. So obviously, we want to find the domain, and we are looking for the correct answer. Right, so now to deal with the domain of this, we have f of x, which is 1/2 to the power x. And if this is the case, right, you'd have like this. So you have exactly this. And now this is sort of your decreasing function. And what is the domain? The domain becomes the set of the x-axis. So right, the set of x values for which it is defined. And it is actually defined entirely, so the domain. Right, so the domain is the entire set of real numbers, because it is it goes all the way in the direction of minus infinity, but it goes all the way to infinity, so that the domain is R. And then now you want to look at option 2 like this, and this is option 1. In what is option 2? Right, so in option 2, therefore, you need to find the domain of this particular function. So if you have f of x is the ln of natural logarithm of 1 minus x. Right. Right, so now you would think that what is the domain of this? Right, anyhow, to see the domain of this is knowing the domain of the log. So the logarithmic function is actually defined whenever 1 minus x is positive, and that means x is less than 1. Whenever x is less than 1, how do you sketch the number line? You have 1, and then you go to the left. So, which means, therefore, that the domain of this would be x is an element of, so this goes all the way to minus infinity, but also it starts from 1 there. So, in other words, is this actually correct? So, we're able to see that indeed this one here is incorrect. But also the first option is actually incorrect as well. But let's look at the third one. The range of g of x, which equals this one, is this range. What is the range of this particular function? We're able to see, therefore, that the range of this particular function is all this, because no matter what you do, the log function is this for ln x. Whenever we graph ln x is this, even when you move it, it will actually have the same range. And the range would be that it is having the range would be minus infinity to infinity, that way. Minus infinity to infinity. So that now, indeed, this one here is correct. In other words, number 3 is correct. And therefore, the correct option is that only 3 is correct. Right, only 3 is correct, because now if you check very carefully, we're able to see that 3 is the correct one. How is 3 the correct one? It is the correct one because it actually is it has the correct range, but 1 and 2 have actually obviously incorrect. Let's just look at the next question of the integration. Right, at this point, I want you to convince me that you actually have a specific ability to find the integral here. I'm giving you like 2 minutes or just a minute. Please try this question and communicate what you think this integral is here. What do you think this integral is here? Right. What do you think this integral is here? Right, so now we actually obviously have the following. Right, we have the following here. So the question is, what exactly do we achieve here as a consequence? What is the integral here? What is the answer to this particular integral? So, right, you need to try this one, and please let us know as soon as you're done. Right, let us know as soon as you're done. Right, there are a couple of ways. So to do this integral, because the polynomial over another polynomial, you need to analyze the degrees. The degree of the numerator simultaneously the degree of the denominator. Right, so if this is the case, then you would have to take these and then say x squared and divide by x squared plus 1. So you have x squared divided by x squared, which is 1. And then we have x squared by 1, which is x squared. 1 by 1 is 1. And you actually put the minus like this. So that we have x squared minus x squared giving us a 0. And this is actually exactly a negative 1. So when you divide x squared by x squared plus 1, you get actually the quotient 1, remainder 1 over x squared plus 1 dx. And therefore, the integral of the 1 with respect to x is x minus, and then the integral of 1 over x squared is actually exactly arctan x plus c. Right, and therefore the question becomes, what exactly is the answer to this particular question? So the answer to this particular question is actually option B. Option B. So the answer is x minus arctan x plus c is the correct integration there. It's actually the required integral here to this particular question. And we move on to the next one. Right, in question 10, we are saying suppose V is the vector with starting point A with coordinates 1, 2, 3, and end point B with coordinates 3, 6, and 7 with length. So in other words, we are then saying that A has the coordinates 1, 2, and 3, and B has the coordinates 3, 6, and 7. Right, suppose V is a vector with a starting point and end point with length V. Choose the correct option. Choose the correct option. Because now we are then saying, we suppose V actually is the vector with starting point this and end point this. So it has the starting point this and it has the end point. So the starting point is A, and you have that the end point is B. Now the question is, what is the vector V? But also find the length of V. Right, I'm giving you a minute to try this particular question. And as soon as you're done, please let us know. Let us know as soon as you're done. As soon as you're done, please let us know. 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 Right, 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 right. Let us know. Let us know. Let us know. Right, so the couple of things obviously you need to take into account. Now, to find a vector V, you would have to take into account that the vector V suppose that the vector V is the vector with starting point this and end point that, which means the end point is 3, 6, 7. The starting point is 1, 2, 3, and therefore you have 3 minus 1, which is 2, 6 minus 2, which is 4, 7 minus 3 gives us a 4. And obviously this becomes a vector, and therefore you would have the pointed parentheses 2, 4, 4. 2, 4, 4. Right, so now it is actually 2, 4, 4, and this gives us the impression, therefore, that the vector V is the vector from A to B, and the vector from A to B is 2, 4, 4. And these can also be seen as a vector that has the components 3 minus 1, 6 minus 2, and then 7 minus 3 that way. In now we have 3 minus 1, which is 2, exactly 6 minus 2, it's a 4, and 7 minus 3, it's exactly a 4. And then now we're asking the question next, what is the length of this vector? So we're finding the length of this vector. If the vector is this, then we're able to know that the length of this vector is the length of the vector from A to B. And so this is exactly what? It's actually 2 squared, 4 squared, 4 squared, which means that the length of B is AB, which is actually the square root of the following. Right, so now you have actually exactly 4 plus 16 plus 16. 4 squared is 16, and now you have 16 plus 16, 32, plus 4, which is actually exactly 36. And the square root of 36 is actually exactly 6 units. So now to actually be in a position to tell which one is the correct result, we are able to see, therefore, that the option A is indeed the correct answer. So, right, we're able to see that the vector V has the coordinates 2, 4, and 4, but the length of the vector V is actually exactly 6 units there. Next point. Next point. Right, the next point. Question 11. Right, question 11. Right, in question 11, we have exactly the following question. Right, so given that h is less equal to f of x, less equal to the sine of x over 2x for all x in this interval, consider the following statements. If ever it happens that h itself is 2, then does it actually mean that the limit of f of x is actually exactly 2? Well, obviously, we're able to first and foremost check the limit of this one. So we have that the limit as x approaches 0 of the sine x over 2x. You can pull out 1/2, meaning you have the limit as x approaches 0 of sine x over x, and this limit is 1/2. Okay, take a look at this. So now, obviously, I mean, for the limit to be 2 here, you'd require that the function, this function itself is such that it is a bounded function, but not only that it is a bounded function, but you would require the fact that what we have is such that this if the limit of f of h is 2, these would also have to be 2 at least, that it is 1/2. So indeed, we're able to see that this one is actually incorrect. It is actually incorrect. Right, so let us continue right now to actually look at that. So if ever the limit of h is 1/2, then would it mean therefore that the limit of f is actually 1/2? Let us think of this most certainly together. Let us think of these most certainly together. Now, there are a couple of things that you need to take into account here. It is that we have a series of functions like this. Right, so you have that h of x is the smallest. And then you have f of x is actually one of the functions here, and this is the sine of x over 2x. The sine of x over 2x. So that f of x, therefore, now is between h and the sine of x over 2x. Right, so as a consequence, then, what actually we're able to achieve here is that the function f is between them. So if then we allow the limit of the h to be 1/2, as much as the limit here is 1/2, what would it mean as a consequence of that? So you need to reason that out. Right, so now the couple of things you need to take into account, but also you need to look at the limit as x tends to 0 of the sine of 3x over x. Right, so this is actually 0 over 0. You can use the L'Hopital rule. The derivative of the sine is 3 cosine 3x over 1. And when you put that into 3 cosine 0, and cosine 0 is actually exactly 3. Now, at this point, we're able to therefore see that the fact that this limit is 3 is correct. But also, we're able to see that if this limit of h is 1/2, because this limit is 1/2, it would actually then imply that the limit of f is also 1/2. And therefore, the correct option would have to be both of this. Right, both of this. Right, because you're dealing with the limits here. But also, I want us to obviously look at the fact that our x lies between, okay, so there is something that is not correct here in this particular question. So now our x itself is such that our x is an element of this interval. Let's take a look at this one. So if our x is an element of this interval, it is written as infinity to 0. union 0 to infinity. Okay, this is not correct. Okay, because this has to be minus. So it has to be x is an element of the interval from minus infinity to 0 union 0 to infinity. So in which case, therefore, what we have here becomes the fact that we have the following. We have the following. Okay, so yeah, this has not been written correctly. So again, I mean, these will be problematic because now when you started the limits as x approaches 0, it can only be that x approaches 0 from a given direction, because obviously now it is must start from minus infinity, so that it means therefore x must be approached either from the left or from the right, either way. Assuming therefore that this should be minus infinity to 0, x is an element of the interval union 0 to infinity. We are sure therefore that this one here is correct. But the question we are asking about number 2, is number 2 correct or not? So we need to reason this out. But now, obviously, we assume that here this is incorrect. And a very correct answer to this would be that 3, we are sure 3 is 100% correct there. So now, which means that we shall actually most certainly be in a position to say that indeed C becomes the most correct answer. C becomes the most correct answer, and move on to the next question. We proceed to the next question. Right now, proceeding to the next question, we actually certainly have the following point. We would have the following point. Right. So, I mean, you need to be in a position to reason this out, but sort of understand what is happening here. Understand what is happening here. Right. So, need to understand what is happening here. Right. So, we proceed to the next point. So now moving to the next point, we have the following. We have the following. Right, when I determine this limit, I'm giving you a minute to try this particular limit question. So in this limit question, you actually have the limit as x approaches infinity of 8x cubed 5x squared plus 2x minus 3 over 1 minus 2x cubed. Right, now the question you're asking is, I mean, what is the correct answer to this? So I'm giving you like a minute, like 1 minute. Please try this limit and let us know as soon as you are done. Okay, let us know as soon as you are done. All right, fine, thanks. Let us know as soon as you are done. Let us know as soon as you are done. Right. Let's check. Let's check. All right, that's fine. That's fine. So that's okay. So right now, because your mic is not working, it's okay. All right. So we shall continue as follows. So what we're gonna do, I understand your mic is not working. So what we're gonna do is to evaluate this limit as x approaches infinity. And what then you're gonna have here, okay, let me see what you can have, what you have here. The answer is 4, okay? You think that the limit is 4, okay, but let us check if 4 is the correct answer. Let us check if 4 is the correct answer, and we are able to get the following. Let us check if 4 is the correct answer. Right, and to check the limit, we need to divide by the highest degree. So now, or the highest power of the x, and you have this, which is x cubed, and to x, you have x cubed minus 3 over x cubed. 1 over x cubed minus 2x over x cubed. Right, so now you have exactly that. So as you divide this, is actually exactly 8, and then there is 5 out of x from x squared divided by x cubed, plus 2 out of x squared minus 3 over x cubed. You divide everything by 1 over x cubed minus 2. Right, as x approaches infinity, this is going to be 8 plus 0 minus 0 divided by 0 minus 2. And this is actually exactly a minus 4. And therefore, the correct answer should be exactly what? Okay, we're getting exactly minus 4, but let us check what exactly we have here. And the correct answer, therefore, is option A, which is a minus 4. We move on to the next point. The next question. Right, in the next question, we have an integral to do, but evaluate the integral by interpreting it in terms of areas. So we have the integral that you need to evaluate by interpreting it in terms of areas, and you have 1 plus the square root of 9 minus x squared, and you have dx. So now the question becomes, what is this integral? I'm giving you a minute to try this particular question. And when you're done, please let us that you're done, and then we can see exactly what to do. Try this one, and as soon as you're done, please let us so that we can see exactly what to do here. We can see exactly what to do here as a consequence. Right, we can see precisely what to do here. Right, so this is actually a very, very excellent move. But we can see exactly what to do here. Okay, let me see what you got. Right, so, all right, okay, that's fine. So that's okay. So it's okay to use the charts to sort of communicate. Yeah, but yeah, we're interested in knowing exactly what the answer is to this one. Knowing what the answer is to this one. What the answer is to this one. So what's the answer? What is the answer? Right, so in the end, then we actually need to have exactly the answer to this particular question, and we see precisely what exactly to do here in a case like this one. So we are good. We are most certainly good, and we are sorted. We are most certainly sorted. We are most certainly sorted. Right, so we're most certainly sorted, and therefore we have the answer. Right, so now we actually are able to get the following. We're able to obviously get the following. We're able to get exactly the following. Right, and what then is exactly the question here? Right, okay, let me see what you got. Okay, that's fine. Having obtained the answer is 3, we check it together. We're going to check it together. So you're supposing the answer is 3, but yeah, we're going to check if indeed the answer is 3 precisely. So we're going to be in a position to sort of come to a conclusion of the answer and see exactly what to do and see what answer we're getting. Right, so let us check what we got. So obviously now this has to do with specific graphs, like there's y equals 1, and then there's also this one here. So if you look at these particular graphs, and there's this circle here, which is the upper circle, where y is actually the same as 9 minus x squared, but also there is y equals 1. There's y equals 1, because we know that this is 3, so y equals 1 is there. And now if we're looking at this and we are saying we're looking at these two functions and graphs, but now the question we're asking is, what exactly is the answer to this? So obviously there are a couple of things we need to take into consideration, but the things we need to take into consideration are actually a set of what we need to have, because we need to consider this, but we are integrating from 0 to 3. Right, so if you integrate from x equals 0 to x equals 3, in other words, our x lies between 0 and 3. And obviously, we actually are looking at this here. Right, so now there are a couple of things, therefore, that are critically important. So you're looking at this line here at x equals 3, and you're looking at the fact that this is sort of going to be some rectangle there. And this rectangle is going to have 1 here and 3, so which means that the integral from 0 to 3 of 1 plus the square root of 9 minus x squared dx. So evaluate the integral by interpreting it in terms of areas. And therefore, this is 1 by 3 plus the integral from 0 to 3 of this. And this one is a quarter circle. Right, so it will be a quarter circle of pi radius. The radius of this circle is 3 units. And then you square this, and this becomes exactly 3 plus exactly 9 pi out of 4. And this is 12 plus 9 pi out of 4. And that is the result in square units. That is the result in square units. So you would have obviously got the answer there. So it would have 3 plus 3 for the rectangle, and then you add also the other area there, which is the area of the required quarter circle. Quarter circle. Quarter circle. F of x is e to the power x ln x. E to the power x ln x. Right, find the derivative of the given function. So I know this one you can do with so much ease. So we know, therefore, that the derivative of this particular function would be by the product rule. Right, by the product rule, you would have, therefore, that derivative of e to the x is e to the x ln x. Plus, you have e to the x, the derivative of the ln is 1 over x. It's 1 over x. So right now, the derivative of this function is e to the power x ln x plus e to the x times 1 over x. So that is what we have got. And we proceed to solve this particular question here as follows. We proceed to solve this particular question as follows. Right, 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 right. Right, 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 right. Right. We continue. Right, 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 right. So we continue to have exactly the following. We continue to have exactly the following. Okay, this is the derivative, and we move to the next point. Right. In the next question, we have f of x, which becomes the cosine of cosine x. Find the derivative of the given function. Do not simplify your answer. Right. So what do you think the derivative of this one is? I know it's a little bit tricky for you to type on the thing, but the question remains, what exactly is the right, try this one. I'm giving you like a minute to try. And as soon as you're done, let us know. Right, as soon as you're done, let us know. As soon as you're done, let us know. As soon as you're done, please alert us. As soon as you're done, please alert us. Right, as soon as you're done, please alert us. Right, sure. Right, as soon as you're done, please indicate that you're done. And then we can see what to do. We can see what to do. Right, we can see exactly what to do. We can see exactly what to do here. Right. So, right. So to find the derivative of this, we would have f prime of x. The derivative of the cosine is the sine of cosine x. By the chain rule, the derivative of the cosine is minus sine x, which is actually f prime of x, which is minus sine x, the sine of cosine x, the sine of cosine x. Right, so right now we have exactly the following here. We have exactly the following exactly here. We have exactly the following here. And this becomes the answer to this particular question, and we move forward. We move forward. We move forward precisely. To the next question. Right, in the next question, we look at C, find the derivative of the given function. Do not simplify your answer. We already have f of x is this. And we know that f of x is exactly that. So if it is 1 over the square root of x squared plus 1, which is x squared plus 1, and this is minus 1/2. We need to find the derivative of this. We need to find the derivative of this. So the derivative of this by the chain rule is f prime of x, which is minus 1/2 x squared plus 1 to the minus 3 over 2. The derivative of that is actually exactly 2x. Right, meaning that in the end, what we have here is the following. Is the following. 2 cancels, so that we have f prime of x, which is minus x divided by x squared plus 1 to the 3 over 2. To the 3 over 2. To exactly the 3 over 2. So that in the end, then we actually have exactly the result here. Okay, right. So obviously now is this the derivative, and how else can this derivative be written? So ponder a little bit on this and make sure you sort of understand what is happening exactly here. Right, so this becomes exactly the answer, and we are done, and we move forward. We move forward. So in other words, this equal sign is obviously out of the picture. Is out of the picture. Right. Right, so we continue. We continue. We continue. Continue. Right. So we continue. Okay, next point. Find the value of values of x such that the vectors are orthogonal. So we've been given a set of 2 vectors, namely 2x, 4 with x, together with 3, 2, and x. So you'd have the following. Right, so find the values of x so that these vectors are orthogonal. I'm giving you a minute to try this one. Please, as soon as you're done, let me know. As soon as you're done, let us know. Right. As soon as you're done, please let us know. Right. As soon as you're done, please let us know. Right. As soon as you're done, please let us know. 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 As soon as you're done, let us know. Right, so obviously we want to find the values of x so that these vectors themselves are orthogonal vectors. So there are a couple of things we need to take into account when studying orthogonal vectors. So now we actually have the following. We actually have the following. Right, so doing these particular vectors, the vectors are orthogonal means that the dot product is identically 0. So you find a dot product 3, 2x. Like that. So now 2x times 3 We have 3 plus 4 times 2, x times x. And then it means, therefore, at this point, we have 6x, 8, x squared equals 0. Like that. So now, you then have, for instance, the following. You then have exactly the following. You want to solve for x, so this is actually x squared plus 6x plus 8 equals 0. And then the factors of x squared are x, and the factors of 8 are 4 together with 2, whose summation is exactly 6. So that we have x equals minus 4 or x equals minus 2. X equals minus 4 or x equals minus 2. And therefore, this becomes the answer. This becomes the answer. So this becomes the answer. Right, so these become the values of x for which this is the case. These become the values of x for which this is exactly the case. Let's reason this out. Let's reason this out. Right. So reason this out. Right. Right. So we have the following. Right. So yeah, we have the following. So now if you have exactly this, to therefore be the answer to this here. To actually be the answer. And this is the answer, x equal to minus 4 or x equal to minus 2. And we move forward to the next question. Next, we need to determine this integral here. The integral of cosine of ln t out of t dt. And we want to determine the following integral. Want to determine the following integral. So to determine this integral, you need to let u be the natural log of t, which is ln t. The derivative of u du is 1 over t dt. So that when we have the integral of the cosine of ln t divided by t dt, it will equal the cosine of u out of t, then the dt is going to be t du. The t cancels, giving us exactly cosine u du, which is the sine of u plus c, which is the sine of the u, which is actually ln t plus c. So the answer becomes exactly the sine of ln t plus c. So take this into account to make sure you understand these exactly. And make sure that you understand these exactly. Right, so in the end, then now you want to determine the integral of x divided by x squared plus 1 dx. So you have the integral of x squared plus 1 dx. So now if this is the integral of x squared plus 1 dx, then we have the following. Right, this is exactly what we have here, exactly. Um, right. So in the end there, if this is the case, we need to determine this exactly. Need to determine this exactly. Right, so determine this here, we're able to say we have the integral of x divided by x squared plus 1 dx. Right, so we actually need to use a couple of things, but one thing is to realize that the derivative of the x squared becomes 2x, and you put 1/2 here, and we have dx like this. But the derivative of the x squared is that. So we know in mathematics that whenever there is a function f of x whose derivative sits in the numerator, then the answer becomes the ln of f of x plus c, and which is 1/2 the ln of x squared plus 1, like that. So that then in the end, we have exactly the following. We have exactly the following. Right, so we have exactly the following. Um, right, so in the end, the question then becomes, this becomes the answer, but it's not the only way to do this particular question. There are surely a couple of ways that can be used to actually do this particular question. And there are therefore a series of questions that we need. Right, so now we're going to obviously focus on some of these questions that we need so that we're able to, or sort of the methods, some methods that we're going to use here to sort of solve this particular question. And we have exactly the following. So if we have the integral of x divided by x squared plus 1 dx, we can also let u be x squared plus 1, and then we are able to find the u, which is 2x dx, which is x divided by u. The dx is du divided by 2x. 1 over u du, which is ln u plus that. The ln of the u is x squared plus 1 plus c. In other words, this will sort of be the answer as well, using what you call the u substitution. The u substitution, the u substitution. Right, so using the u substitution, we're able to actually be in a position to get the actual result using the u substitution. Using the u substitution. U substitution. Okay, we're good. Using the u substitution. So now we have exactly the following. We have exactly the following. We have exactly the following. Right, we proceed to the next question. Right, so now we have this particular one, and we have the integral of x divided by the square root of x squared plus 1 dx. And we want to actually be in a position to find the actual result out of this. So the question we're asking then is, what is the answer to this particular question? What is the answer to this particular question? Um, so now, what exactly do we have here? What exactly do we have here? Right, what exactly do we have here? So now, this one can best be done by using the U substitution. Let U be x squared plus 1. Du is 2x dx, so that we have the integral of this one, x squared plus 1 dx. And then the integral of x divided by the square root of u, the dx, is du over that, which is 1/2. The x cancels the x cancels the x. The x cancels the x, and we're able to get 1/2, and then you have u to the minus 1/2 du. And therefore, this is 2 to the 1/2 plus c. And these 2 cancels, the 2 cancels the 1/2, giving us u to the 1/2. And therefore, the answer here is the square root of u plus c. But upon careful examination of this, we're able to see, therefore, that this is the square root of the x squared plus 1, because the u is x squared plus 1, plus the arbitrary constant of integration c. Take a look at this and make sure that you sort of understand what's happening. Right. 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 So this is what we have. This actually is what we have here. So take a moment to reason this out and make sure that you are able to understand exactly what is happening here. Right. So we then have the following. We then have the following. Right. We then have the following. So we actually have the result on the board. Make sure that you understand what is happening, and you understand what is happening, that you understand it very, very well. As we move forward to the next question, and in the next question, we look at more things that remain very, very important, and we solve the next question. Right, so in the next case, we're going to focus on these particular integrals. So we have the integral of 3 to the power t, the secant squared of 3 to the power t dt. Right, so now, I mean, with this then, what exactly are we able to sort of achieve here? What exactly are we sort of able to achieve in this case? We want to find the answer to this particular integral, but obviously, I mean, there are things we need to remember. We need to spend time on the properties of integrals. Like if you have the secant squared of x dx, we know that this is the tangent of x plus c. So that if we let u be 3 to the power t, then the du of this would be the derivative of this function is 3 to the power t, the ln of 3. That is actually the derivative, and then you put dt here. So that now, at this point, you can actually be in a position to make dt the subject. So dt becomes du divided by 3 to the t ln 3. Hence the integral. The integral of this. We have 3 to the t, and this is the secant squared of u. The dt is du divided by 3 to the t ln 3. The 3 to the t cancels out, leaving us exactly with 1 over ln 3, the integral of the secant squared u du. Okay, note that we're taking out the ln 3, the 1 over ln 3 out. The reason for the removal of the ln 3 is simply because the ln 3 is a constant. So that we have 1 over ln 3, and then we have the tangent of u plus c, 1 over ln 3, and we have the tangent of u. What is u? It is actually exactly 3 to the t plus 1. 3 to the t plus 1. Right, 3 to the t plus 1. 3 to the t plus 1. Right, so this would sort of be the integral that we have of the given function. This integral that we have of the given function is a very, very important integral of the function. It's a very important integral of the function. So we have the following. So now, if you have this particular integral here, and you have the integral of x squared and y squared. So you have x squared plus y squared plus z squared is 6x minus 4y minus 10z. The center of the plane of the sphere is what? We need to find the center of this sphere. But how do we find the center of the sphere? To find the center of the sphere, we write x squared minus 6x, and then you write y squared plus 4y, and then you write z squared plus 10z, and this result is 0. We have x squared minus 6x, and then we take the minus 6, we halve it. We square that, but you see, simultaneously, we need to also do it on the further right. So we're going to have, for example, minus 6 out of 2, which you square this, and then you have y squared with 4y. You have 4 out of 2, you square this. Z squared 10z, 10 over 2, you square this. So you have 4 out of 2, you square this. You have 10 out of 2, you also square this. X minus 3 squared y plus 2, you square this, z plus 5, and we square that. So that you have a 9, a 4, and a 25. So now, obviously this is x minus 3, which you square, y plus 2, which you square. Simultaneously, you have z plus 5, which you happen to square. Right, and upon checking this very carefully, performing the addition, you can see that is actually 38, because the 9 plus 4 is 13, and 13 plus 25 is exactly 38. So in the end, then you have the following. So the center then is 3 minus 2 minus 5. What is the radius? The radius is the square root of 38. Okay, so the radius becomes the square root. We take the square root of this. Right, so the center is 3 minus 2 and minus 5. Simultaneously, then that is the center we've got. And in this question, what you also mentioned the radius, and the radius is equal to the square root of 38 units. So in other words, that is what we have, 2 pi 19 square root of 38 units. 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 And this here becomes the radius. Becomes the radius. And we move forward. We move forward. All right, now if you look at question 18, it's about graphs, and we're saying consider the graph of H primed. Consider the graph of H primed. Consider the graph of H primed. Right, so now the question is, at which value or values in each domain does the function H have a local maximum? At which value or values in its domain does the function H have a local maximum value or values? So now, if this is H primed, you're able to see that the derivative is negative here. Simultaneously, the derivative is positive there. Negative there, positive there, and the derivative is negative there, is positive there. So now, if this is true, then if ever the derivative is positive, and then suddenly the derivative becomes negative, or rather the derivative first, I want to say, for example, what is happening here, the derivative is negative, so we're running downslope. In other words, the original function runs downslope. The original function h runs upslope. The original function h runs here. So obviously this point here is positive, so it means that it runs upslope, but obviously here at a decreasing rate, so it's upslope, upslope. And then here it runs downslope. The original function runs downslope. If here it runs upslope and then it runs downslope, then the local maximum is at actually x equal to 1. It is actually at x equal to 1. So the question is what? Right, it is actually exactly at this value here. But looking at this is actually at -2, which means that this is going to be at 2. And at which values in its domain that's the function h have. So it is at h of 2, or simultaneously you can actually be in a position to then say here it occurs at x equals 2, which is the x in the domain. And at that point, that is where you can see the function is running as a positive gradient and then a negative gradient there. A negative gradient, right? So obviously, I mean, look at this, think about this carefully as we move forward, to the next point, to the next point, to the next point. So we proceed as follows. We proceed as follows. Right. Right. Right, 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 right. So we have the following. We have exactly the following. Right, so we have the following. Right, so we actually move on to the next question. Right now, you consider the graph of G double primed. Consider the graph of G double primed. Right, so if you consider the graph of G double primed, at which value of values in its domain does the function G change concavity? Right, so now at which value of values in its domain does the function G change concavity? So we proceed as follows. Now, I want us to look at this particular question, but this question focuses on this being the graph of the G double primed. But at which values in its domain does the function G change concavity? So we're looking at concavity. But now concavity, so we're able to see that here it's concave down because the derivative is negative. Here the second derivative is positive. Here the second derivative is negative. And therefore it is concave down. Here it's concave up. Concave down, concave up. At which value of values in its domain does the function change concavity? At which values in its domain does the function change concavity? Right, so we're able to therefore see that it is clearly at the following values. So you can see that here it's concave down and then it's concave up. And then here it's concave down and there it's concave up. So what then becomes very evident is the fact that it changes concavity at the following points. Right, for instance, we can see at G of -1, we have at G of 2, we have at G of 5. So we have G of -1, G of 2, and also G of 5. We really can see that there are changes in the concavity there. The changes in the concavity because it's concave down, then it's concave up, then it's concave down. So there's a change from up to down concavity wise. And here is concave down, then it becomes concave up. And what we're able to see, therefore, it actually at which values in its domain. So obviously this happens at x minus 1 and x2, also x equals 5. And you are able to see changes here. We're able to see changes here. We're able to see changes here. We're able to see changes exactly here. So then we have exactly the following. Then we have exactly the following. Okay. Now complete the definition. The function f decreases on an interval I if what? You must be able to complete this particular statement. Complete the definition. The function f decreases on an interval I if what happens? When is this the case? So it decreases if you have that f of x1 is greater than f of x2 whenever x1 is smaller than x2 in the interval I. Complete the definition. The function f decreases on an interval I if what happens? Right. We have the following. Right. We have exactly the following. So complete the definition. The function f decreases on an interval I if what happens? So it actually therefore decreases on an interval I if f of x1 is actually greater than f of x2 whenever x1 is less than x2 in I. In I. In I exactly. In I exactly. Okay, so we are actually we have exactly the following. We continue. We continue. We continue. We continue. Okay. Okay, we have exactly the following. Okay. We have exactly the following. We have exactly the following. So now we move forward. Right, so now we're looking at actually this question part B, and we're saying that given f of x equals x cubed in x, f primed is x squared, open bracket, 3 ln x plus 1, and f double primed is x, open bracket, 6 ln x. All right. So we have the following. Right. So we have the following. We have exactly the following. So now, given f of x equals this, and f prime f of x is x cubed ln x, f prime of x is x squared, open bracket 3 ln x plus 1, and f double prime is x, open bracket 6 ln x plus 5. Find the intervals on which the function f is decreasing. Right, so we understand therefore that for the function f to be decreasing, it actually means that the first derivative of the function is negative. And this means that we have x squared 3 ln x plus 1 is negative. So now there are a couple of things to note, that whenever we note that let us obviously take note of the following aspects here. Let us take note of the following aspects here. Right, if ever this derivative is negative, I want us to examine these, but examine these very, very carefully. So we're interested in finding the actual critical points that arise from this. So now, if you have the critical points that arise from this, we have exactly the following. So this would be, for instance, at 0, because you would have that x squared 3 ln x plus 1 is 0, which means x is 0, x equals minus 1. Okay, so at this point, you're going to have, for instance, for the expression within the parentheses, it will be 3 ln x is minus 1. X is actually e to the power minus 1 over 3. So that now you have e to the power minus 1 over 3. Like that. So that then in the end, we have the following. All right, so that you have 0. And then you would have exactly, you can put the 0 here, and here you put e to the power minus 1 over 3. So we have x squared, 3 ln x plus 1. And then now you're going to have also the x squared, 3 ln x plus 1. So you do the sign table here. You do the sign table here. So that now, this is what we're able to achieve. X squared now, for any x here, is going to be plus, 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 because even if you take an x that is negative and you square it, it's going to be plus. Between 0 and e to the power minus 1/3, you're still going to have whatever number that's here. If you square it, it's going to be plus. Bigger than this, whatever number you're going to square it, you get a plus. Now here you choose a random number, for instance, that is smaller than 0. So here the ln of a negative number is not, so you can say it does not quite exist, or you can say undefined. Simultaneously, you can then say, we don't take the ln of the negative numbers in this real analysis module. Between this and that, you would have, for example, a number, And whatever you're going to take, for instance, if you have here a number that's close to 0, and the number that's close to 0, you put it there, and it's actually going to be a number that's going to yield a negative. And so this is going to be negative. You can use a calculator for that. You can take this 0 plus this and divide by 2 to get an intermediate number and put it in the place of the x. And then are able to see that you can have a negative. A number bigger than this would be a number like 2, so that you have a positive there. So you continue. So now, so in the end, then you are dealing with those numbers that are smaller than 0. Okay, you multiply now the positive and this one here. You can see that you can still see it does not exist, or you can say undefined. Okay, multiply these two, you get a negative. Multiply positive by negative, you get a negative. Multiply the positive and positive, you get a positive there. Right, so which means therefore, whatever you have here is the following. For example, you examine, for example, the x squared. You would have to examine x squared, and 3 ln x plus 1 equals 0. This would mean x is 0, or if this is 0, that would mean x is 0, or that would mean that 3 ln x plus 1 is also 0. This would mean ln x is minus 1 out of 3. Solving for x is e to the power minus 1 out of 3. Right, and as a consequence, what are we actually able to achieve here? So we're interested in parts wherever now we have the positivity. We want rather the negativity, so that this is decreasing. So we can see therefore that whenever x is bigger than 0, whenever x is bigger than 0, what then are we able to achieve here? So obviously, whenever x is bigger than 0, you would have, for instance, a negativity there, because whenever x is less than 0, then you have does not exist or undefined. X bigger than 0, you have a negative, and also so it's decreasing here, but it is again increasing there. So it is actually therefore such that you can then say it actually decreases. Just write that one. It decreases whenever x is the element of 0 and e to the power minus 1/3. It decreases whenever x is an element of the interval from 0 to e to the power minus 1/3. Right. Okay, so that is sort of obviously the answer to that particular question. That is sort of the answer to that particular question. That is sort of the answer to that particular question. So that is what we have. That is exactly what we have. That is exactly what we have here. That is exactly what we have. Right. So we have exactly the following. Okay, we continue to analyze more questions. We continue to analyze more questions as follows. Find the intervals on which the function is concave upward. Find the intervals on which the function is concave upward. So now, concave upward would mean that we have f double primed 6 ln x plus 5. Concave upward would mean that this is greater than 0, which means 6 ln x plus 5 is greater than 0. Well, I mean, first we can write it a bit more meaningfully, that concave upward would suggest that this is greater than 0. And this would mean the second derivative is greater than 0. We know that from this given question, the second derivative is x 6 ln x plus 5. So that you have x 6 ln x plus 5, and this is greater than 0. Right, and now whenever this equals 0, whenever x 6 ln x plus 5 equals 0, it will mean that x is 0 or 6 ln x or 6 ln x plus 5 equals 0, which means that we have 6 ln x equals minus 5. And you can say minus 5 out of 6. And therefore, you'd have x is e to the power minus 5 out of 6. So that in the end, then we get the following. So that in the end, then we have 0, e to the power minus 5 out of 6. So that now we have x here. So you have plus 5 here. So whenever here, whenever x is negative, you'll have a negative here, and then here you have positive for x. But here, whenever you have numbers that are negative, you'd have that this one does not exist, and this one here is either does not exist, or you can say it is undefined. And this one is negative, and this one is positive. And then now you'd have to do the product here. So you're going to do x 6 ln x plus 5. And so what we're able to achieve here, if you multiply these two, so you can say it does not exist. You can say undefined. And therefore now you multiply these two, you get a negative, and here you multiply, you get a positive. Right, so now when is it concave up? It's when this second derivative is positive, and you can see that when you are on the right of this. And then you can say concave up. Concave up whenever x is an element of the interval. So you start from e to the power minus 5 out of 6 to infinity. Like that. Right, and I think that it was awesome having this discussion right now at the moment. As a homework, I'm going to give a brief homework for you to process and, think about. And whenever you have the chance to communicate your feedback, you can send us feedback of the answer. You can send us feedback of the answer. Right, so now use logarithmic differentiation to find dy dx if this is the case. So we've been given y equals 3 to the power x. The tangent of 3x divided by the square root of x squared plus x cubed. So that in the end, we have to use logarithmic differentiation to find dy dx. And this is actually the given function, and we need to find dy dx by using what we call logarithmic differentiation. Need to find dy dx by using logarithmic differentiation. So now this exactly is what you need to do. And this is actually exactly a homework. Right. Right. We must thank you for joining us. It was awesome having this discussion. Until next time, I believe we need to have a discussion this weekend. You shall advise on the time. Right. Otherwise, for now, thank you so much for your discussion. Until next time, take care and have a good day, and goodbye. Goodbye.